So let us see the question number 6.02 from GATE 1990. It's an 8-mark question coming from X-Ray. The polycrystalline specimen of a cubic metal is subjected to copper coil for radiation having a wavelength of 1.5418 angstroms, and the diffractometer test is obtained. If the 2 theta angle of the first 3 peaks is 38, 44.18 and 64.25 respectively, determine the crystal structure and the lattice parameter of the cubic lattice. Okay. So ultimately, we need to find the crystal structure and lattice parameter. Okay. So first we need to find the crystal structure. Based on crystal structure, you can find your A. Okay. So that means our first job is to find the crystal structure. Okay. How do we find out? If you can remember, the value of D11 by D of 200 proportional to sin of theta 2 by sin of theta 1 is equal to 1.15 for an FCC, right? Whereas for BCC, D of 110 by D of 200 proportional to sin of theta 2 by sin of theta 1 is equal to 1.414 for a BCC or simple T, right? We know these shortcuts, and it is actually GATE 2013 question. Okay, so to eliminate the chance, first if you can calculate sin of theta 2 by sin of theta 1, if it is coming 1.15, then our job is easy. We can directly understand that it is an FCC structure, right? So let us do that. He has given the first 3 peaks of 38, 44.18 and 64.25 of the 2 theta values, right? It's not theta. So sin of theta 2 by sin of theta 1 is equal to sin of 44.18, that means 22.09 by sin of 38, that means 38 by 2 is equal to 19. If you can check this value in our GATE calculator, it is 1.155. 1.155. That means our cubic lattice is a FCC type, right? It's an FCC, right? Now we know the cubic lattice. From that, we understood that the first big 38 is actually coming from 111, right? Because the 111 will be the first plane in an FCC. Now our job is easy. So we are asked to find the lattice parameter. That means from the relation D is equal to A by root of H square plus K square plus L square. To know D, you should know your D and HKL value. Our HKL values are 111. That means our job is now to find the value of D, right? How do you find D? We will go back to our Bragg's law, which says that L lambda is equal to 2D sin theta, right? Put sin 19 here. So n being the 1, because it's always a first order diffraction, and lambda he has given us 1.5418 angstroms. Okay, 1.5418 angstroms. 2 into D we need to find. That means 1.5418 by 2 into sin 19 is our D value. If you can simplify this value, 1.5418 by 1.5418 by 2 and by sin 19 value. The value is 2.367. The D value is 2.367 angstroms. Okay. Now we need to put the value in our general formula. So that means 2.367 is equal to A by root 3. That means A is equal to 2.367 into root 3. Right? Therefore, the value of 2.367 into 1.732 is our A value in angstrom. It is 4.10. Therefore, A is equal to 4.10 angstrom. Right? So, our final answer is the given polycrystalline specimen is of FCC type and the lattice parameter is 4.10 angstrom.